So I've decided to do 10 experiments in 10 minutes using household products. I have bought a collected mix of items including straws, food colouring, white carnations, corn flour, alcohol and string. So let's kick off with experiment 1. Colour changing carnations. The hypothesis, or prediction, is that by adding food colour to the food source, the petals should become ablaze. A beautiful, multicoloured array, vibrant, splashy and flamboyant, and perhaps a little bit chintzy. Number 2, the giant minion. You'll need a gummy minion and some water, and I must stress no minions were hurt during this experiment. Next, balloon rockets. The hypothesis: a controlled rocket linear-powered balloon flight across the lab. So, take the string and tie it to something sturdy. Unravel the string to about 4 metres, or what developers have assured me is the average size family kitchen. And tie the other end to something equally substantial, so it's anchored at both ends. But remember, and this is the important bit, remember to feed the string through a straw first. This straw is your host, the catalyst for controlled speed. Once full of air, tie the end. With the aid of experienced technicians, attach the balloon to the straw using sellotape. Now, with a small amount of theatrics, cut the knot off the tied end of the balloon. Ta-da! This experiment is all about air and thrust. Thrust is a pushing force created by energy. In a real rocket, thrust is created by the force of burning rocket fuel. In this instance, though, it's just literally my hot air. So basically, thrust comes from the energy of the balloon forcing my halitosis out. That's bad breath. Moving on to experiment 4. The sweet diffusion of colour. The hypothesis is to create myriad colour in a controlled environment and observe the interaction of colour. I also want to see how many times I can say colour. Place the coloured sweets symmetrically in a flat dish, a little bit like a clock. Common sense leads most people to expect the colours to mix, resulting in orange where red and yellow meets, and green where blue and yellow mix. Hold on, green mates blue and yellow. Yeah, that's right, yeah. We'll check progress again in a bit. The next experiment requires alcohol. Drink it. Experiment 7. Glow-in-the-dark carnation. The hypothesis is to create a glow-in-the-dark flower. You'll need a highlighter pen. Make sure the fluorescent pen glows under black light. My little yellow flower-yielding matador, let's call him Pedro, tends to be the most reliable. And his reward for reliability? Drawn and quartered. Use a knife or saw to cut open Pedro and expose the fibres which contain the ink. Squeeze the dye from the ink pad into a small amount of water. Trim the end of the flower so it's able to take up the water and place the flower in the water with the ink. How many times can I say water? So, plants absorb water through the stem to nourish the head. You may be surprised to learn that many flowers actually glow under the light of fluorescent. Some insects which pollinate the flowers can see the ultraviolet. It's usually white flowers that are ultraviolet coloured. You can accentuate the glow of white flowers under black light by feeding them tonic water, which contains quinine. So there you go. I found washing machines don't tend to be more attractive, but like the flower, they're slightly more eye-catching when, ruined with ultraviolet ink. Sorry. Right, quickly revisit the sweet diffusion experiment. You'll notice the colours spread out away from each chocolate in a semi-circular looking fashion. Where they meet, the colourful current appears to abruptly stop dead in their tracks. The reason they do this is to do with density gradients. Initially, the current spread in every direction, but at the junction where the two colours meet, the concentration or density of the sugars is equal on both sides. Nobody is chucking content-sized chocolate buttons into the sea, but there is a gigantic density-driven current, and it's also called the thermaline circulation, or ocean conveyor belt, and this is actually how ocean currents work. Now, back to the cornflower and the non-Newtonian disco dancer. Right, add cornflour to a dish, add a bit of water, You will note I'm not using tap water. This is simply because I have champagne taste on lemonade money. In other words, it's all about image. So, now, give it a stir. You may find this a strange experience. The more you stir, the thicker it gets. Stop and it becomes thin. A non-Newtonian fluid is a fluid with properties that differ in any way from those of Newtonian fluids. I think honey is a non-Newtonian fluid, but we're going to make specifically oobleck. Put your fingers in there, move them with vigour, and presto, it's hard and crumbly. Now to really work the magic. Get some cling film, pour the mix onto the cling film, put some non-dad music on, something with a bit of a beeline, in other words, a bit of bass, or in geeky words, something that will power out at least 90 hertz or more. Geeky. And watch as neighbours start gathering around the house thinking there's an illegal rave. In fairness, it doesn't have to be that loud, just no Justin Bieber. So, how does this work? When you move the mixture slowly, the suspended particles have time to move and slowly slip past each other. So the mixture acts like a liquid, and it can easily flow. However, when you suddenly poke the mixture, the particles don't have enough time to move out of the way, so they form a more rigid structure. I tell you, quicksand is an example of a non-Newtonian fluid. It works much like the corn-flour mixture. Instead of cornstarch particles floating in water, they're kind of individual grains of sand suspended in water. So, of course, if you fall into a pit of quicksand, you should always try and slowly pull your way out. If you were to move too fast, it becomes solid and you get stuck. Hence the whole quicksand scenario. So, when you've done the experiment, you are left with a pair of ruined speakers and you're eventually left with a kind of solid substance as the water vapour escapes from what's left. That was fun though, I like that one. But you're going to love this one. Number 8, the inside-out egg. Get a raw egg, put it in a sock. I did actually later have to use a pair of tights to get the G-force up enough. And swing it like you just don't care. You don't care about the way you look, you don't care about ruining socks, you don't care about your child's face. Swing it, baby, but don't wave your hands in the air. When you're done, hard boil the egg. What you're left with is an inside-out egg yolk. So the yolk is effectively on the outside and the white is in the middle. So this experiment is about centrifugal force, or away from centre. The force travelling in a circle pushes the denser material, in this case the yolk, outwards. It's also quite good for impressing guests at dinner parties. Good, huh? Balloon break. Right, now time to deshell the egg I boiled earlier. While we wait, some egg facts. A hen, as it gets older, produces larger eggs. Eggs contain the highest protein you can buy. It's one of the few foods which actually contain vitamin D. And also, an egg will actually age more in a day than a whole week in the fridge. Come on, Darcy, get on with it. Experiment 9. Teach yourself to suck eggs. The hypothesis? Well, let's wait with bated breath on this one. I nearly said breast. Now, what should have happened here is the lit match heats the air inside the bottle. The air is then heated, it expands and takes up more room. As the heated air expands, some of it escapes out of the bottle. When the matches go out, the air inside the bottle cools and contracts, which takes up less room. This, of course, creates a lower pressure inside the bottle than obviously on the outside, and the greater pressure outside forces the egg to get sucked into the bottle. Had it have happened, to get the egg back out of the bottle, tilt the bottle and blow air into it, and make sure you get out of the way. Okay, time for experiment number 10, can crusher. My faithful assistant daughter will add a tiny drop of water to this empty can. while one of my other children ran round in circles having drunk the contents of the can. Okay, now carry it over to the water and place it upside down in the cold water and...
Ready, everyone? Ready?
That's right, scare the bejeebers out of your kids. So, the sweets are diffusing well, creating the density to separate the colours nicely. Minion is getting bigger. I can see the fluorescence in the centre of the carnation now. And I can just about see the red food colouring ascending up the flower. Let's hit the lights. Well, in this experiment the carnation did grow. I had to ad-lib a little, but... back to teaching me to suck eggs. Light the candles. Drop them in. And... and drink. You must be wondering what happened to our little friend, the minion. Well, here he is before our little experiment, measuring just 2 centimetres. You may remember earlier in the video we swan dived him into a glass of water. Now look at the little blighter. When the minion is added to water, the water molecules move into the little man by means of osmosis. So the boring bit, osmosis is the movement of solvent molecules, or water, through a partially permeable membrane into an area of lighter solute, the gummy bear minion gelatine basically. It takes it in and holds the water in to equalise the solute concentration on both sides. So he's gluttonous, or in this case glutinous, and rotund, like a London banker. So what do we conclude? Well, items that are non-living, like our minion friend here, are semi-permeable. Osmosis is the flow of water from high concentration to low concentration, referred to often as tonicity. Okay, so hear me out. Tonicity, in layman's terms, is the measure of pressure. So if I'd had salted water, because this is interesting, if I'd had salted water, the minion would actually do what's called hypotonicity, which is again through the process of osmosis. It's moving the molecules through the membrane, but because it's salt water, and I'll get there in the end, the concentration of tonicity means it's more, and it will suck out the water from the minion, any existing water, and therefore the minion will become smaller. How many times can I say minion? So, water enters the minion, making it bigger when the water is not salted, because the tonicity of the minion is higher than the water. Get it?